Hi, everyone. This is Rob Gray from ASU and the Perception and Action podcast, back with another article review. In this episode, I want to look at this interesting application of movement sonification for training anticipation. So, the paper I'm looking at is this one, published in Journal of Multimodal User Interfaces earlier this year, The Effect of Eye Movement Sonification on Visual Search Patterns and Anticipation in Novices. So the background for this is, I've talked about this a lot on the podcast. You can go back and look at older episodes on gaze behavior. We know that typically elite performers have different gaze strategies as compared to lesser skilled performers. That's one of the things that seems to define skill. They look at different things at different times. Sometimes they look at things for longer, like in the quiet eye effect. Sometimes they look at things for shorter. Sometimes they look at more things. Sometimes they look at less things, but it typically will find that they're different. And so one idea people have had is maybe we can kind of shortcut, track practice of the skill and skill development by just giving a lesser skilled athlete the gaze behavior pattern an elite performer, right? So we could teach them, look here, look here, look here, look here, right? That might result in better performance on the court. But for the most part, the attempts to do this have not really worked. And I talked about this way back in episode 24C, and I talked about it a bit in the book, in my book. There's a bunch of examples of this. An example of a movement example of this is the robo golf, where we try to get you to move in a certain way. Eye movement example is this interesting study by Andre Klosterman, a study where they basically train people, lesser skilled volleyball players, to have the gaze pattern of the not a skilled volleyball player. And the way that this has been done in the past, there's not too many of these studies, but there's been a few, is that it's been done visually. So you have a novice watch a video and you give them kind of visual cues of where to look and when, right? So that you circle, in this case, it's circles, you could colors, right? So there's been a few of those. And in their study, they found no effect at all, either on performance, right? It didn't help at all. Novices kind of somewhat can adopt the gaze pattern, but it doesn't really seem to help performance. As I said, there's a couple other studies that are kind of thing. The only real exception to gaze training that seems to work is quiet eye training, right? And that one, though, you're not really getting an athlete to adopt a gaze pattern, right? A strategy of moving here or there. You're just getting them to keep their eyes fixated for longer, right? So it's a lot easier, right? So that's kind of the background. The research question investigated in this study is, can we improve this by adding sound, right? So we know there's kind of two layers to this, right? We know that in learning, right, most people learn better when in multimodal conditions, multisensory, right? So when you're reading a book, if there's an illustration, right? So there's this general multisensory effect of benefits of learning. We also know, as I've talked about in episode 350, and I talked a lot about in my book, the benefits of movement sonification, right? Movement sonification is taking your movements, your body movements, tracking them and turning them into a sound, right? A sound cue. So if I move my hand up, maybe the sound gets louder, right? There's been a few studies showing the benefits of this, right? For multiple reasons. It gives the athlete more information about their movement that they don't normally have. It doesn't interfere with visual processing, right? So they can still look around the scene without having to look for also a cue or a color or a circle, right? So there's lots of kind of benefits. And I'll get back to this in a second. So in this study, what they wanted to do was to use eye movement sonification to train anticipation in badminton. And what they're going to use is a traditional temporal occlusion task, right? So they're going to show uh, badminton players videos of a person hitting a forehand in badminton, a stroke. They're going to occlude it at a certain point, and you have to judge whether it's left or right, right? So it's a passive anticipation task, which I have issues with, right? It's not really. I think it's not really studying the skill, but the same kind of skill. It's kind of changing the task, right? There's no time constraints, for example, when you have to make a verbal response. But anyway, so that's the basic design. You were doing a temporal occlusion class, judging left or right. They used 5 expert badminton players. These were used to identify the ideal search pattern, right? So what they're going to use is a traditional kind of approach of, here's the correct way to do it. Let's see if we can get you to do it, right? So the idea, there's one solution, okay? So they had 5, and then they had 40 novices. What they did was had the experts watch video clips of someone serving, and they basically looked where they looked, and they did quite a bit for this. They occluded some parts and see if it messed them up. They did different temporal occlusion points to see. So they did a lot of work. They just didn't take the data and use it, add just by itself. They did some analysis to see what mattered. So they did these 20 clips. They look where they're going. They defined 5 areas of interest on the opponent: trunk, legs, hand, racket, and head. And they used this once they figured out the pattern and the timing of where they looked for the kind of overall best performance. They took that and they sonified it, right? And I'll show you what it was in a second. Okay, so that's what they did first. So they identified this is the ideal, optimal visual search pattern. Look here, then here, then here, right? They then took their novice players, the 40 players, and they split them into 2 groups, right? So they had a control group, which is a visual group. They were essentially during the training. So both groups during pre-test and post-test and a retention test 7 days later, they did a traditional temporal occlusion task with just visual, right? So they're just watching the video and have to say left, right. Between the pre and post test, there was obviously training. In the control group, and there was a control group and the audio-visual group. The control group, they were given verbal feedback about where they looked, and they're also told where to look verbally, right? So they're told when the video clip started to please look at the trunk first, then the hand, then the racket for anticipating the shot direction of the shot. So they were given a coaching instruction about where to look. Okay, so that was, and it was done on 50% of the trials, right? So during the training. The audiovisual group, right, they wore headphones that synchronize, sonify, and their eye movements were sonified, right? So if you move your eyes, it created a sound. In particular, what they did was create what we typically call pull feedback, right? So the sound that the person heard depended on how far away they were from the expert ideal search pattern. If you were right on it, you didn't hear anything, right? Or you heard a pleasant sound. It depended on the condition. But here's the search pattern. And so 160 milliseconds before racket shuttle contact, you're supposed to be looking at the trunk. Then from 160 to 180 milliseconds before contact, you look at the arm. Then the racket, 80 milliseconds to shuttle contact. So it's basically trunk, arm, racket, and they're telling you the times. If there was a deviation between this, so for example, say it was 100 milliseconds, 50 milliseconds before contact, and you were looking at the person's waist, or were looking at the person's face instead of the trunk, they were told they would hear an unpleasant sound, right? And they would try to reduce that sound, right? So take note of the timing here, right? 160 milliseconds. So we're going from 160 milliseconds before contact to contact, right? Okay. And so this is, as I said, is a pull feedback. It's trying to pull you towards the correct solution, right? By giving you a feedback that you want to reduce the sound, okay? Right? So you want to reduce this unpleasant sound, okay? So what did they find, right? So the first thing, if we look at accuracy in the judgment task, the 2 groups were the same at pre-test, but at post-test, the response accuracy of the audio-visual group that had their eye movement sonified was significantly higher by about 15% on average, both right after test training and 7 days later. Okay. Their decision time, how long it took to make their decision of direction, was also shorter by about 80 milliseconds or so. Again, both at the retention. So getting clear, nice performance effects. Okay. They also look in terms of gaze behavior. They looked where the 2 groups looked the most, right? And they looked at both incorrect and correct responses. The effects were kind of the same. What they found was that the group that did the group that was trained with eye movement sonification looked at the trunk and the hand more often. Whereas the group that was not the control group looked at the racket more often, right? So we get in some clearer gaze. So they seem to be adopting somewhat the strategy of looking at the trunk, okay? So overall, pretty nice effects, right? Seem to be benefits of the sonification. So I think it's an interesting study. The only thing I would question is really what is driving this effect, right? So given the timeline of the experiment, I really doubt that participants could learn to use the feedback, right? So think about it. You move your eye, it's 60 milliseconds before you have to make the point of contact. You hear a sharp sound telling your eyes are in the wrong place, right? You have to send a signal to move your eyes, and you don't even know which direction, right? To get that information, generate an eye movement signal, get the feedback in 160 milliseconds, right? It doesn't seem long enough to me, that the idea that they could be pulling them towards the correct location, right? What I think is going on here, and this is consistent with previous research I discussed in the book. There's a race speed skating study that used movement sonification that compared this kind of pull feedback towards an ideal solution versus just sonifying your eye movements, right? So what I think is going on here for me is it's not that they're learning an ideal solution, it's that they're getting more information and getting more awareness about where they're looking and when, right? When you typically look at something, you have no idea. People have very poor awareness whether they're looking at the trunk or the head at any moment. Giving people a sound is giving you awareness about where you're looking. And that's what was found in that speed skating study. The awareness, just sonifying it and making the sound change as you move your eyes, worked way better than trying to pull person towards an ideal solution, right? So I would like to see a follow-up study in which they had a pull feedback, just awareness condition where the eye movements were just sonified and there was no ideal solution, and the control group. But anyway, I think this is an interesting idea. Obviously, it requires special equipment. The other thing, of course, I would like to see is it doing a more real task, right? Not a passive judgment where you have, a long time to make a decision, a binary decision. Okay. So that's it for today's episode. Thanks for joining me. Cheers for now, and keep them coupled.